Welcome into the first of our NAT labs. In this particular lab, we're going to set up static NAT from a router inside our network to an IP address on the outside of our NAT device so that we can ping out to the internet. Now this is our lab topology. It's very simple, 3 routers, and I picked routers for all 3 of these just so we can actually do debug IP ICMP on each of these consoles and see what IP address is actually sending the pings. Makes for a very easy way to verify that our NAT is actually performing as we expect it. Now just to prove there's nothing up my sleeve, let me go over here to the client, and I'm going to try to ping this internet address, 100.50.25.1. So I'll do ping 100.50.25.1, and you'll notice that it times out every time. Specifically, I have a route to get to the internet. The internet doesn't have a route to get back to me because I'm not running any routing protocols on any of these routers. Now again, this lab is available to you as the NAT lab in your work files. And again, usual caveats apply, bring your own iOS, etc., etc. So our first configuration is fairly straightforward. We want to set up a static NAT on this NAT router here to allow 192.168.1.1 to NAT out via 100.50.25.10, for example. And we're going to set up a static NAT to do exactly that. We'll ping out to the internet to make sure we can ping, and then we'll validate on the internet that we're actually seeing that .10 address coming from our NAT box. So let's go to our NAT router and we do config T. The first thing we have to do for any NAT configuration is we have to tell the router which interface is the outside address and which interface is the inside address. Now let's expand this over here on GNS3. That's an easy way of telling what interface is which. So Fast Ethernet 00 is connected to the internet. Fast Ethernet 01 is our client. So what we'll do is we'll go interface Fast Ethernet 0/0. We'll do IP NAT outside. And then we'll do interface Fast Ethernet 0/1, do IP NAT inside. That tells the router when you perform these NAT commands, which way do you go. So I don't know why I exited all the way out of config mode, because we're going to be in config mode to set up the rest of the NATs. So the commands we'll use in our config is IP NAT, and first we tell the NAT engine where are our addresses coming from. So our addresses are going from inside to outside. So we'll do IP NAT inside. We're then going to define the source. So we're defining the source IP address. And this is going to be a static mapping. We'll use the route map in the list when we talk about the dynamic NATs in the other labs. But for now, this is going to be a static mapping. And the inside local address is 192.168.1.1. And next we are to specify the global address or the interface. Now you would specify an interface if you had a DHCP address on one of your interfaces that you're using for your outbound NAT. For example, if this router is connected to the internet, you don't know what your outside IP address is because in theory your outside IP address could change depending on how your internet provider handles their DHCP leases. In this case, we do know what address we're wanting to NAT out as. We're going to NAT out as 100.50.25.10. We also have other options for our static NAT. However, at the CCNA level, we're not going to use any of them. So we'll hit enter, and now we have a static NAT set up. So let's go over here on the internet router, and let's do debug IP ICMP. And now we'll see every ICMP packet that hits this guy. So let's go to our client, and we'll do ping 100.50.25.1. And it seems to fail for some reason. Now, why does my NAT fail? I've got the NAT set up, the NAT router's on the same subnet. Well, even though you're not actually doing any routing at your NAT router, you still have to have a default route pointing at that router. And I specifically made this failure to demonstrate that if you don't have a default route, the client doesn't know where to send the traffic, so it just kind of gives up. So we'll go into config mode. We'll do IP route. We'll just set a static route for 0.0.0.0, which tells it it's a default route. And we'll point it at 192.168.1.254. Let's make sure that's the right address. And it is. So we'll do that. Now let's try our pings again. And after a few timeouts, because we're all virtualized here, we get success rate back, 2 out of 5. At least it succeeded. And let's look on the console of the internet here. You'll notice that the echo reply sent source of me destination 100.50.25.10, which shows me that that was the source address for the NAT as it came through the NAT router. Now let's go over here on the client and let's do debug IP ICMP on this guy as well. Let's ping back this .10 address from the internet and see what address ends up on the client. So let's do ping 100.50.25.10. We get a 100% success rate. And on the client, we see the NAT address as 192.168.1.1. If we wanted to have a different address on the inside of the network when this came back through the NAT, we could set up a NAT going from outside to inside, saying that when you see traffic from this outside address, you put it on 192.168.1.10, for example. But we didn't set that up because really we only want the NAT to go one way. So again, static NAT's fairly straightforward, very easy to set up, very easy to verify if you've got routers all along the way, or if you're really good at reading ARP tables in Windows OSs. And that concludes our first lab on static NATs.